In this section, we want to introduce polynomial expressions, review some of the basic components, key pieces of a polynomial expression, and then build our way up to factoring techniques. A polynomial is the sum or difference of terms consisting of a variable raised to a whole number power. Every polynomial expression has a degree, a leading term, and a leading coefficient. To determine all of that, we look for the term where the variable is raised to the highest power. In this case, n, since those remaining variables are n minus 1, n minus 2, those values are getting smaller. The largest power is the degree of that polynomial. The coefficient in front of that variable being raised to the highest power is the leading coefficient. And that term taken as a whole, the coefficient and the variable component, is referred to as the leading term. If a polynomial has 3 or fewer terms, then we can give it a specific designation. A monomial is a polynomial with just a single term, something like 8x squared. A binomial is a polynomial with 2 terms, something like 4x minus 7 or 6y cubed minus 4y. And a trinomial is a polynomial with 3 terms, something like 3x to the 6th plus 4x squared plus 2. In the next few examples, what we want to do is identify the type of the polynomial, the degree, and then the leading coefficient of that polynomial. In example 1, we have negative 7x to the 7th. This is a monomial since we only have one term. Since there's only one term, the power that that term has is the degree of the polynomial. So this polynomial is degree 7. And the leading coefficient will be the coefficient for that term, which in this case will be negative 7. In example 2, we have a binomial, since we have a polynomial with 2 terms. The degree of this polynomial will be 5. And that leading coefficient will be 10. In example 3, we have a trinomial. Since we have a polynomial with 3 terms, in this case, the degree of that polynomial will be 8. We need to be careful with problems like this because in the previous examples we've had those exponents kind of occurring in descending order. The largest exponent has always been the first term, but in this case, the variable being raised to the highest power is in the second term. So we'll have a degree of 8. And then the coefficient for that term will be negative 10. So we want to be careful if our polynomial powers aren't in descending order. The leading coefficient, the degree of that polynomial, might not be determined by the first term in that polynomial. What we do then, often, and it helps us with other tasks we'll have to carry on in math courses later on, is write polynomials in descending order So we could rearrange this and rewrite it as negative 10 w to the 8th power minus 5 w to the 4th power plus 8. Writing a polynomial in that descending order has a number of advantages. One is just making it obvious. We just have to look at the first term and know that that's our leading term.